Hi everyone. So let's start the class today, right? So let's take a small recap of what we had done in the previous classes. So first thing, we were discussing the state chart diagram. In the state chart diagram, I had introduced the three concepts of transition, right? I told you that there is state, there is transition, and there are events. Okay, so we had also looked at some examples of state chart diagram. I had also drawn a diagram, so let's go back and have a look. Yeah, so yes, so we had drawn a state chart diagram and we had basically kind of modeled a CD player, right? CD player was an object that we had actually chosen, and we looked at some of the states of the CD player. We looked at the events, we looked at how the transitions happen, right? And we also discussed what is an active state, and in the last class we talked about the initial state and the final state. Other than that, we also discussed a condition when you can have a non-deterministic state chart diagram when there are transitions happening with the same event. That means the same event can cause different kinds of transition. So in this case, we have play, which is an event, but in one scenario, in one condition, when you press play, the object remains in the closed state. But in another condition, when you press play or when a play event occurs, right, the object kind of changes its state from the closed state to the playing state. And when that happens, we have to specify the conditions, and these conditions in the state chart diagram make a state chart diagram deterministic, and these conditions are called as the guard conditions. So these were some of the concepts that we had discussed in the previous class. Today we will be extending these concepts, and we will be looking at something called as exit actions, right? And we will also talk about the entry actions. So what exactly are actions? So before we actually move on, let's draw the state chart diagram once again, so that we'll draw the state chart diagram with conditions this time, so we know exactly, we have a clear picture. So as I had told you before, a state is always labeled with a rectangle which has square edges. So in our example that we had taken, we have three different states: closed, playing, and the open state, right? So let's write our three states. Then we have one transition, that is play, right? And in this case, the guard condition is that there is no CD. So if there is no CD, then from the closed state, the object will remain in the closed state. In the second state, if you press the stop button, or if there is a stop event, nothing will happen here. Once again, the object will remain in the closed state. However, if there is a CD which is present, right, and a play event occurs, and the condition is CD present, then what will happen? Yes, there will be a change in the state. If I press stop, or if the stop event occurs, then once again from the playing state, the CD player moves on to the closed state. Alright, while the CD player is playing, if the play event occurs, or if you initiate a play method, right, it will remain in the playing state. Similarly, from the playing state, if you load, right, so if you kind of press the load button, or the load functionality, or the load event is triggered, then from the playing state it moves on to the open state, and from the open state it can go to the playing state if you again initiate the play event and if the CD is present, right? So these are the old concepts that we have been discussing, and nothing has changed here. So it's all the concepts which I am actually talking about, they have already been discussed in the class. So once again, from the open state, if you press stop button, or if you initiate a stop method or trigger a stop event, then it will remain in the open state. And once again, from the closed state, you can come to the open state if you press the load button or trigger the load event, right? And once again, from the open state, if you have noticed a CD player, then it's the same button for, kind of opening and closing the shutter, that you have the tray which comes out, right? There's a tray which comes out where you place the CD. If you press load once again, the tray again goes back. So if I press load or initiate the load event, the train will once again go back. The tray will once again go back to the closed state, right? Now, what we have done here is, yes, is there anything which I have? Yeah, from the open state, if I once again press play, if I once again press play, and what happens is, when it's open and if you have the CD, so what happens is it will start playing, but first it goes to the closed state, and from the closed state it will start playing. So if the CD player is open, that means the tray is open, and if there is a CD, yes, it will go and start playing. But if there is no CD, it will just close. Okay, so let's write that condition as well. So if I press play, and if there is no CD, it will just go ahead and close. But if there is a CD, it will start playing. So from open, if I press play, if there's a CD is present, it will start playing. Otherwise, it will go to the closed state. All right. Now, I told you that we are discussing actions, right? What exactly are actions? Now, actions are performed when transition fires, right? And it is not required to mention the actions all the time. That means when we are talking about actions, we are talking about transitions. So basically, what happens when a particular transition fires? Now, that is represented by actions. So if I look at this example, and if I have to specify the actions, what actions would be performed in these transitions? So let's look at some of the transitions. So let's look at this one, okay, here. So in order to write the action, you need to use this slant line, right? And you need to write what happens when this particular transition happens. So in this case, it's in the open state, right? And when it goes to the playing state, there is something which happens. What is the action? Close, let me write it again. Close drawer. So the drawer which is there, that closes, right? So that is one of the action which happens in this transition. Similarly here also we have close drawer. This is again an action which is happening, right? And in this case, open drawer. This is again an action which happens when this transition happens. Similarly, in this case, what will be the action? The action will be close drawer. That means from the open state, it is going to the closed state. What is the event? Event is load. Transition is the arrow which is being shown. And what happens when the transition happens? The drawer gets closed. Okay. So these are basically the ones which I have highlighted in this diagram. They are basically the actions which are performed when a particular transition happens. Okay. So when I talk about actions, actions are nothing but they are performed when a transition fires. So you can write the actions with, if you think that it is required to write the action for more clarity, then you can go ahead and write the actions along with the transition. But it is not a compulsory, thing to actually add an action. Okay, you can leave the transition as it is. You may not add these actions, or if you think that yes, it's going to add more clarity, then you can also add some actions. Okay, so these are actions. Now there are something called as entry and exit actions. And entry and exit actions are properties of states. Okay, now whenever an object arrives or leaves at the state, then there are two kinds of actions which are performed inside a state, and they are called as entry and exit actions. So for example, let's take an object. So let's say that this is an object, right? And this is my rounded rectangle, and I can write the name of the state here. So I write the state as playing, right? And there is another state called as open. Here is my open state. And from the playing state, you can go to the open state, and from the open state, you can go back to the playing state. right? And how do you do that? What will be the event? The load, right? And what is the action? Open drawer. That's the action which happens, from the playing state when you press the load button. And if you press play when the state of an object is when the object is in the open state, and when you press the play button or the play event is triggered, and if the CD is present, right, what will happen is an action of close drawer will take place and the CD will start playing. Now if you've noticed here, what I've done is I have divided this rectangle, this rounded rectangle, into two parts. Okay, on the top I have written the name of the state in which that object will come to, and the remaining portion which I have left empty, there I will be specifying the entry and exit action. So as I told you, that entry and exit actions are properties of a state. Okay, when an object enters a particular state, the entry action is fired. Action is some kind of event. Action is some kind of functionality. Okay, and similarly, when an object leaves a state, that means an exit action is fired. That means, how do we know that the object has entered a particular state? Now, in order to find out when the object has entered a particular state and when that object has left a particular state, we can make use of the entry and exit actions. Now, if the entry action is fired, that means that object has entered that particular state. And if an exit action is fired, that means that object leaves that particular state. Okay, so entry and exit actions are important because they tell you whether the object has entered a particular state or whether the object has left a particular state. Okay, for example, when you're playing the CD player, what happens? Right, so let's say that there are two different kinds of actions which are performed. So let's say the first one you can write as entry. So what will happen when the object will enter the playing state, and another one will be exit. So when can I say that the object has left the playing state? Okay, so you must have kind of noticed when you are actually playing a CD player, right? So when you put the CD and you press the play button, before the CD starts playing, you must have noticed that there is a head. There will be some kind of a mechanical head which has a small LED. It's kind of a laser, light will be there, and that head basically moves around and goes to a particular track and settles itself there, and then the music system or the CD starts playing. You must have noticed that. Now we can say that when that head will start moving, that's the time we can say that yes, the object has entered the playing state. So movement of that mechanical head, right, to find the start of the track can be called as an entry action. Okay, so we can say that when the object, when the CD player or the object that is in question or that we are discussing right now, starts moving its head and finds the starting point of the track and places its head there, that means we can say that yes, the object has now entered the playing state. Okay, and how do we say that yes, the object has left the playing state? When that head moves away from the track, that means if that mechanical head, which consists of a small laser point, if that moves away, that means if it lifts itself up, we can say that yes, it is no longer playing because that head has removed from its track position. So then we can say that yes, the object has left its playing state. Okay, so we can write the entry and the exit actions for each of the states, and this is also not compulsory to write, but if you think that yes, it's important, you can specify it. So for the example that we just discussed, we can write the entry head as, you can write it in your own language. You can say find starting track and lower the head. Okay, and the exit could be raise the head. Okay, so this becomes your entry action and the other one becomes your exit action. So if you look at this, this is my entry action, this is my exit action. Now entry and exit actions are basically the the two actions which are the properties of a state, and they signify when an object enters that state and when an object leaves the state. Now other than these entry and exit actions, these are basically, for example, if this is the state, then you have something like this. Okay, this is the entry point, so this is the entry gate and this is the exit gate. All right, so when the object, this functionality gets triggered, that means this is the entry action, then we can say that yes, the object has already entered this playing state. And when this particular functionality or some function is triggered, that means we can say the object has now exited this particular state. And in between this, whatever happens, that's the actual functionality of that particular object, right, in that particular state. That means the main purpose of that object in this playing state is what? To play, right? Play a track. But before playing the track, it has to perform entry action. That means it has to find the track, the starting track, and then place the head. Second thing is, after the playing of the track is over, when it is supposed to leave that particular phase, right, then it has to trigger an exit action. That means it has to raise the head, and then we can say that yes, the object has left that particular state. So this is your entry action, this is your exit action. Okay, so let me just highlight that in a different color. So this is your entry action, which states that an object has already entered its state. This is an exit action, which tells you that the object is left the state, and whatever is there in the center, this is the actual functionality, what happens in that particular state. So this is called as activities. Okay, so this is called as activities. So you have entry action, you have exit action, and you have activities. Activities are the actual functionality which is supposed to be happening in this particular phase. So I can also specify the activity inside the state, and that will be, what will be the activity here? Play track. Okay, so play track is an activity. So if you look at the UML diagram which I have drawn for this particular state, this is the activity which tells you what that object is going to do in that particular state. This is your exit action, which basically signifies that once this is triggered, the object has left the state. And this is an entry action, which basically signifies that the object has entered that particular state. Okay, now what happens is, sometimes without even like most of the time when there is a change of state, I told you that there is an event. Okay, and event basically causes a trigger, it causes a transition, and that transition basically causes the state of an object to change. All right, now sometimes what happens is, you can trigger a transition without any event happening. For example, like let me give you a small example of that. For example, what happens is, suppose you're playing the last track. Okay, so let's say here is an object, and this object is in the playing state. Okay, and here is another state called as closed. Okay, so if the object is in the playing state, yes, it will start playing, right? And if I press the play button, nothing will happen, it will continue to play, right? That means here there is some transition happening, but this transition is not causing a change in the state. Such kind of transition are called as internal transitions. Okay, internal transitions do not change the state of a object. That means when you press the play button, the object will once again be in that state. That means initial transition is happening, but the object comes back into the same state. That means you can have internal transitions do not change any state. Okay, now what I will also tell you is that, yes, I was discussing about sometimes without any event taking place, there will be a change in state. Now for example, this object is playing. Okay, so here is a CD player which is playing, and when I press stop, it will go to the closed state. Okay, when the stop event happens, it will go to the closed state. Now there is another condition under which this object player will go to the closed state without any actual event occurring. Okay, now when will that particular condition be triggered, and when will that object go back to the closed state when there is no event? Now that condition is, suppose the music player is playing the last track, and it is the last track, and once it finishes the last track, what happens is automatically the music player will close. That means it will not continue to play. So you start with track 1, 2, 3, 4, 5, 6. It will continue to play track 1, 2, 3, 4, 5, 6. And when it comes to the last track, after finishing the last track, it will go automatically to the closed state. So in case of a condition like this, an event is not happening. There is no event which is taking place. There is no event which is causing a transition. It's some condition. It's some condition. Okay, so such condition, for example, the last track played. So let me write that condition. Last track played. Okay, so if a last track is being played, from the playing state, once the last track is completed, it will automatically go to the closed state. That means there are two ways by which the object can go from playing to closed. One is if you press the stop button and a stop event occurs, and the other one is if the last track completes, automatically the object will go to the closed state. Now this kind of transition where there is no event, okay, this kind of transition, there is no event, but the activity completes when everything is over. That means these are transitions which happen. The transition is happening without any event, but when is the transition happening? When the activity is completed. That means when the last track is played and the complete activity is completed, then the transition happens. So these transitions will not have any event, and they are called as completion transition. Let me write it down. So they are called as completion transitions. Okay, so remember that if an activity completes uninterrupted, that means it keeps playing and it finishes completely, it can trigger a completion transition. And these transition, you do not have to give any event in the label, and you only need to put the condition under which this transition happens. So this is called as a completion transition. Now I told you about internal transitions. Okay, now sometimes you notice that you will have some buttons, like for example excuse me, suppose you have a state and the object is playing, right? So you have your entry action. I'm not going to write it. You will have your exit action, which I already explained. I'm not going to write it. And you have activity, right? Like I told you, it was play track. Okay, now you will notice that sometimes there are some buttons. Okay, like for example, if you're watching a TV show, if you're watching a cable TV on your set-top box, right, and suppose the match is going on, there will be a button on your remote. Okay, some button will be there on your remote, like for example info, right? If you press the info button, what will happen is there will be no interruption in the state. That means the state in which that particular object is will remain. That means the TV will continue to play, but there will be a small pop-up which will come, which will show you some kind of information. Okay, now sometimes when you're watching a movie, right, suppose the movie is going on and you want to know which movie is it. Suppose what is the name of the movie. So you'll find that on the remote you will have a button. So when you press the button, right, the movie will continue to play, but there will be a small pop-up which comes and it will tell you that what is the actual name of the movie and who are the actors and all that. A small piece of information will come. Similarly, in the music system also you have some info button. Most of the music system will have an info button. So when you press the info button, it will tell you, how much time is remaining, how much more time is left for the music, that particular song to get over. So in these kind of transitions, there is some transitions happening. That means when you press a button, there is some event, right? But that event is not causing a change in the state. That means while the movie is playing, from side some information comes, shows it to you, and then it disappears, but there is no change in the state of that object. Okay, so such kind of events which do not change the state. Okay, so if it doesn't change the state, that means it does not execute the entry and exit action. So entry exit actions are not at all affected. It doesn't affect even the playing track. Okay, what it does is it just initiates a second functionality without triggering the entry or exit action. If exit and entry actions are triggered, only if exit and entry actions are triggered, then only what happens is your object changes its state. But if the entry and exit actions do not get triggered, then the object does not change its state. So in case of internal transitions, right, transitions where there is no entry and exit action which is triggered, there is no change in the state. So suppose there is a button called info button. What it does is it suppose displays time. Okay, so this particular transition is called as internal transition. So if you press the info button or initiate the info method, what happens is entry exit actions are not triggered. The object continues to be in that particular state. There is an internal transition happening, but that transition is not causing a change in the state. Okay, so such kind of events are called as, such kind of transitions which are happening within a particular state are called as internal transitions. They do not change any state, and that's the reason they do not execute entry and exit actions. Okay, so what we discussed today was we started with what are what you call yes, we had a quick review of the previous classes. Then I talked to you about actions, what exactly are actions, right? And then I told you about the entry and exit actions. And I also showed you how to represent an action in a UML diagram, in a state chart diagram. So in this case, this closed drawer, right? Closed drawer, then open drawer, these are all actions that you can represent in a state chart diagram. Then you can also, I told you what exactly entry and exit actions are. These are properties of the state, and every state will have some entry and exit actions. Okay, so what do they help us in showing? It tells us when an object has entered a state and when an object leaves a state. Also, I told you about an activity. Activity is that actual functionality which is performed in that particular state. Okay, and I then discussed the completion transition. That means sometimes even without event happening, right, an activity can complete, right? So if an activity completes uninterrupted, that means no event comes and interrupts it. Okay, then it is called as a completion transition. And you don't have to put any event label there, because these are not triggered by events, but these are triggered by some conditions. So in this example, you've seen that the condition I have mentioned is that last track played. So once the last track is played, the object slowly changes its state from playing to closed. That means a transition happens, and that transition is called as a completion transition. And the last part, I told you what internal transitions are. That means these are transitions which happen internally inside a particular state. They do not change the state, and because the state does not change, that means entry and exit actions are not executed or triggered. Okay, an example I told you that if you're watching a movie and if you press a button, some information button, the movie will continue to play at the background. That means there is no change in the state of your system, but some information is displayed to you. That means you are basically executing another function while that big function is still continuing to execute or run. Okay, so in today's class we will cover till this much, and if you have any doubts, please let me know, right? You can always message me and tell me if you have any doubts. And in the next class we will talk about what composite states are, right? So when we have a state chart diagram, the state chart diagrams can be very complicated because you can have so many different states. So composite state chart diagram is a way of simplifying these state chart diagrams. It's a way by which we can, group the state chart diagrams to make our diagrams more simple. Okay, so I think this should be fine for today. So we will continue in the next class. Please let me know if you have any doubts. So till the next class, see you. Bye bye.